close your eyes for a moment and imagine taking a breath underwater, not the panicked gasp of drowning, but a slow, peaceful inhalation as if the ocean itself were breathing with you. What if I told you there are forests beneath the waves that do exactly that, exhaling oxygen and inhaling the rhythms of the tide? Places where light dances through water and life flourishes in ways that rival any rainforest on land. Tonight, we descend together into one of Earth's most enchanting and overlooked ecosystems. Are you ready to discover what lies beneath? We begin our journey at the surface, where waves roll in endless rhythm against rocky shores. Here, at the edge of continents where cold, nutrient-rich currents meet shallow coastal waters, an invisible boundary exists. Step beyond it, slip beneath the foam, and you enter another world entirely. The sounds of air and wind are replaced by the muted symphony of water, a liquid silence that somehow feels full of presence. This is the gateway to the kelp forest, and as we descend, leaving behind the world of air breathers, we prepare to witness something extraordinary. The light above begins to shift and dance, transforming into something almost sacred. As you sink deeper, the temperature drops and your body adjusts to the embrace of the sea. The water here along the Pacific coast is cold, often hovering around 50 to 60 degrees, yet it pulses with life. This chill is not hostile but invigorating, carrying with it the dissolved nutrients that feed entire ecosystems. Around you, the water is not empty but filled with tiny drifting particles, plankton and organic matter suspended in the current like stars in a liquid cosmos. Each speck catches the light, and you realize you are not alone. You are swimming through a living medium, and every movement sends ripples through this interconnected web. The seafloor rises to meet you, and suddenly structures emerge from the gloom. At first, they appear as dark vertical lines, shadowy pillars reaching upward. But as your eyes adjust, you see them for what they are. These are the stipes of giant kelp, towering stalks that stretch from the rocky bottom toward the distant surface, some reaching heights of over 100 feet. Imagine a forest where every tree grows in reverse, roots clinging to stone below while their branches spread across the ceiling of light above. This is not a place of soil and roots, but of rock and holdfasts, and it operates by rules unlike any terrestrial forest you have ever known. You pause here, hovering in the water column, and let yourself simply observe. The kelp sways with the surge of the ocean, bending and flowing in unison as if choreographed by an unseen conductor. There is a rhythm here, a pulse that matches the waves above. Each swell sends energy down through the water, and the kelp responds, leaning and recovering in an endless dance. This motion is hypnotic, and you find yourself swaying with it, becoming part of the forest's breathing. How strange it is to feel so peaceful in a place so alien to your nature. Yet here you are, suspended between the bottom and the surface, in a cathedral made of water and light. In the distance, you notice movement. A harbor seal glides effortlessly through the kelp, its body torpedo-shaped and perfectly adapted to this liquid realm. It regards you with large, dark eyes full of curiosity before twisting away with a flick of its rear flippers, disappearing into the forest faster than you could ever hope to follow. Marine mammals like this are the forest's most graceful inhabitants, equally at home in the open ocean and within these towering algae. They come here to hunt, to rest, and to play among the swaying fronds. Watching the seal vanish, you are reminded that you are a visitor here, a guest in a world that belongs to creatures far more adapted to its demands. The light here is different from anything you experience on land. It is diffused, softened by its passage through water, and tinted green and blue by the absorption of red wavelengths. Long before you reach significant depth, the world has already transformed into a palette of cool tones. Reds and oranges are muted or invisible, while blues and greens dominate. This color shift affects everything, from the appearance of the kelp itself to the fish that dart between the fronds. Yet despite this limitation, or perhaps because of it, the kelp forest possesses a beauty that is uniquely its own, a serene aesthetic born from the interplay of light and liquid. As you settle onto a boulder near the forest floor, you take a moment to appreciate where you are. Above you, the canopy stretches like a living ceiling, blocking much of the direct sunlight, but allowing dappled patterns to shift and move across the rocks. Around you, the stipes rise like the columns of some ancient temple, and between them, life teems in every direction. Small fish hover in schools, invertebrates cling to rocks and kelp alike, and somewhere nearby, you sense the presence of larger predators patrolling their territory. This is a complete ecosystem, as complex and interconnected as any forest on land, and you're about to explore every layer of it. You push off gently from the rock and begin to swim deeper into the forest. The kelp grows denser here, the stipes packed more closely together, creating corridors and clearings that shift with every surge. Navigating this space requires a gentle touch and an awareness of your surroundings. Brush against a stipe and it gives way easily, its flexible structure designed to bend rather than break under the force of the ocean. This flexibility is key to the kelp's survival, allowing it to endure powerful storms and surging currents that would snap rigid structures like twigs. As you move, you begin to understand that this forest is built not on strength alone, but on adaptation and resilience. To truly understand the kelp forest, we must start at its foundation. Descending to the rocky seafloor, you find yourself face to face with the Holdfast, the remarkable structure that anchors each kelp plant to the substrate. Unlike the roots of terrestrial trees, which burrow deep into soil to extract nutrients and water, the Holdfast serves a single purpose: to grip. It is a tangle of root-like structures called haptera, which spread across the rock surface and wedge themselves into every crack and crevice. Run your hand over one and you feel its rough, firm texture, a grip so strong that even the most violent storms often cannot dislodge mature kelp. This is the foundation upon which the entire forest is built. Look closer at the holdfast and you discover it is not just an anchor but a habitat in itself. Within the maze of haptera, countless small creatures make their homes. Tiny brittle stars wind their arms through the gaps, small crabs scuttle in and out of crevices, and juvenile fish find shelter from predators in this labyrinthine fortress. The holdfast is one of the most densely populated microhabitats in the entire forest, a miniature ecosystem supporting dozens of species in a space no larger than a basketball. It reminds you that in nature, every structure serves multiple purposes, and even the anchor of a plant becomes a city for the small and vulnerable. The rocks to which the holdfasts cling are not chosen at random. Kelp requires hard substrate, stable surfaces that will not shift or bury the holdfast under sediment. This is why kelp forests are found along rocky coastlines rather than sandy beaches. The Pacific coast of North America, with its rugged underwater topography of boulders, reefs, and rocky shelves, provides ideal conditions. Here, where tectonic forces have created a landscape of stone beneath the waves, the kelp can take hold and thrive. Without these rocks, without this foundation, the forest could not exist. It is a reminder that even the most robust ecosystems depend on specific conditions, on the right combination of factors aligning perfectly. From each holdfast, a single stipe emerges, or sometimes multiple stipes in larger, older kelp. The transition from holdfast to stipe is seamless, a natural continuation of structure and purpose. The stipe itself is hollow and flexible, filled with gas, filled bladders that will develop higher up to provide buoyancy. But here at the base, it is solid and strong, designed to withstand the immense forces that ocean currents and surge can exert. Touch the stipe near the holdfast and you feel its firmness, a texture almost rubbery yet resilient. This is living tissue, constantly growing, constantly repairing itself, a testament to the vitality that pulses through every part of the kelp plant. Kelp grows at an astonishing rate, among the fastest growing organisms on Earth. Under optimal conditions, giant kelp can grow more than 2 feet per day, adding length to its stipe and fronds with incredible speed. This rapid growth is fueled by the cold, nutrient-rich waters in which it thrives. The kelp absorbs nutrients directly from the surrounding seawater through its entire surface, not just through root structures like land plants. It is a testament to the productivity of these marine ecosystems, where the right combination of light, temperature, and nutrients creates an explosion of growth that rivals the most fertile terrestrial environments. Can you imagine a tree that grows 2 feet in a single day? Here, beneath the waves, it is simply the way of life. The seafloor around the holdfasts is not barren but covered in a diverse array of other organisms. Encrusting coralline algae paint the rocks in shades of pink and purple, creating a colorful mosaic that contrasts beautifully with the golden brown kelp. Sea urchins graze slowly across these surfaces, their spines creating shadows that dance with the surge. Sea stars of various species cling to vertical surfaces, and in the cracks and overhangs you spot the waving tentacles of anemones waiting for food to drift within reach. This community of organisms exists in the shadow of the kelp, benefiting from its presence while also contributing to the overall health and diversity of the ecosystem. Everything here is connected, each species playing its role in the grand tapestry of life. Among the rocks you notice areas where kelp once grew but has since disappeared, leaving behind only the bare holdfast or sometimes just a scar on the stone. Kelp plants do not live forever. They are subject to storms, disease, predation, and simple old age. When a kelp is torn away, it creates an opening, a gap in the forest canopy that allows light to reach the seafloor. This light triggers the germination of new kelp spores that have been lying dormant, waiting for their chance. The forest is constantly renewing itself, with old giants falling and young kelp racing to take their place. It is a cycle as old as the forest itself, death and rebirth intertwined in an endless dance. As you prepare to ascend from the forest floor, you take one last look at the holdfasts around you. Each one represents not just an individual plant, but the foundation of countless lives. The fish that shelter in the canopy above depend on these anchors holding fast against the storm. The invertebrates that live within the haptera depend on this structure for their homes. Even the sea otters that will appear later in our journey depend on the kelp forest these holdfasts support. In the grand architecture of the kelp forest, the holdfast may be hidden and humble, but it is absolutely essential. Without these anchors gripping the stone, none of what you're about to see in the layers above could exist. It is a powerful reminder that foundations matter, whether in nature or in life itself. Rising from the holdfasts, the stipes of giant kelp create a vertical architecture unlike anything found on land. These are not rigid structures, but flexible, hollow tubes filled with pneumatocysts, gas-filled bladders that provide buoyancy and keep the kelp reaching toward the light. As you swim upward alongside a stipe, you run your hand along its surface and feel the smooth, slightly slimy texture of its outer layer. This mucus-like coating is not unpleasant, but serves a purpose, reducing drag as water flows past and protecting the kelp from harmful organisms. The stipe pulses with life, and at intervals along its length, you see the distinctive bulges of the pneumatocysts, each one like a small balloon helping to lift the massive plant toward the surface. The stipes do not rise alone, but in groves, creating an underwater forest that mirrors the density and structure of terrestrial woodlands. Swim through a mature kelp forest and you navigate between these pillars much as you would walk between trees on land. The spacing varies, sometimes wide clearings where light penetrates easily, other times dense thickets where the stipes stand so close together that you must carefully thread your way through. This variation creates different microhabitats, each supporting different communities of organisms. In the open areas, larger fish patrol and hunt, while in the dense sections, smaller creatures find safety in numbers and complexity. The architecture of the stipes themselves shapes the entire ecosystem, determining where species can live and how they interact. Along the length of each stipe, you begin to notice the passengers. Kelp provides surface area, a hard substrate in the water column that countless organisms use as a foundation for their own lives. Encrusting bryozoans, delicate colonial animals that look like lace, cover sections of older stipes. Tiny hydroids extend their polyps to capture passing plankton. Small snails graze on the film of algae that grows on the kelp's surface. These organisms are epiphytes, living on but not harming their kelp host. They transform each stipe from a simple structure into a complex, three-dimensional habitat supporting an entire community of life. It is a city within a forest, and every vertical surface is prime real estate. As you continue your ascent through the mid-water zone, the quality of light begins to change. You are leaving the dimness of the seafloor and entering a realm where sunlight penetrates more freely. The kelp responds to this light, its growth directed always upward toward the brightest source. This phototropism, the movement toward light, is what gives the kelp forest its characteristic vertical structure. Unlike terrestrial forests where trees spread their canopies horizontally to capture sunlight, kelp extends vertically through the water column, creating layers of habitat at different depths. Each layer receives different amounts of light and harbors different communities of organisms, making the kelp forest one of the most vertically stratified ecosystems on Earth. Midway up the stipe, in what we might call the understory of the kelp forest, life reaches a peak of diversity. Here, enough light penetrates for photosynthesis, but the environment remains sheltered from the strongest currents and surge. Schools of fish hover in this zone, including rockfish of various species, their mottled coloring helping them blend with the kelp. These fish are not just visitors, but residents, spending their entire lives within the forest's protective embrace. They feed on smaller fish and invertebrates, court mates among the swaying fronds, and hide from larger predators like seals and sea lions. Watch a school of blue rockfish drift past, their movements synchronized and graceful, and you see how perfectly adapted they are to this three-dimensional environment. The stipes sway constantly with the motion of the ocean, and this movement is hypnotic to witness. Unlike the chaotic turbulence of a storm-tossed sea, the sway of kelp in normal conditions is rhythmic and predictable, matching the period of the waves passing overhead. Each surge sends a pulse of energy through the forest, and the kelp bends in response, then recovers, then bends again. This constant motion serves multiple purposes. It prevents sediment from settling on the kelp's surface, it helps circulate water and nutrients around the plant, and it creates a dynamic environment that many fish species use to their advantage. Small fish can ride the surge to conserve energy, while predators learn to time their strikes with the rhythm of the kelp's movement. As you rise higher still, approaching the upper reaches of the stipe, you begin to see the first fronds branching off from the main stem. These lateral fronds extend horizontally from the stipe, each one attached by its own pneumaticist that keeps it buoyant and spread out to catch maximum sunlight. The fronds are where most of the kelp's photosynthesis occurs, and they are the most delicate part of the plant. Run your fingers along a frond and feel its thin, blade-like structure, so different from the robust stipe. These fronds are constantly being produced, growing from the base of the stipe near the holdfast and being pushed upward as new tissue is added below. The oldest fronds are at the top, and they are also the first to be torn away by storms or consumed by herbivores. Looking down from this vantage point in the upper water column, you gain a new perspective on the forest. Below you, the stipes descend into darkness, a colonnade of pillars disappearing into the blue-green depths. Above you, the canopy beckons, a shimmering ceiling of golden-brown fronds silhouetted against the bright surface. You are suspended between two worlds, the dark depths and the sunlit surface, and the kelp forest exists in both simultaneously. It is a bridge between realms, allowing creatures of the surface waters and the deep to interact in ways that would be impossible in open ocean. This vertical integration, this connection between top and bottom, is what makes the kelp forest such a productive and dynamic ecosystem. And you, floating here in the middle, are witnessing the full expression of that connection. Ascending through the final meters of water, you break into the canopy layer, and suddenly the world transforms. Here, where the fronds of countless kelp plants spread across the surface, the ocean takes on an entirely different character. Light floods in from above, no longer filtered through tens of meters of water but streaming directly through the fronds that bob and sway just inches below the surface. The color shifts from the blue-green of the depths to a warm amber glow as sunlight illuminates the kelp from above and below simultaneously. Swimming on your back beneath the canopy, you look up at a living ceiling, a tapestry of overlapping fronds that shift and move with each passing wave. It is like lying beneath a forest canopy on land, except here the leaves are golden and the wind is replaced by water. The canopy is not a solid barrier, but a patchwork of light and shadow. Gaps exist where kelp has not yet grown or where fronds have been torn away, and through these windows shafts of pure sunlight pierce down into the forest below. These light columns are mesmerizing to watch, especially when they catch floating particles or passing fish, illuminating them in spotlights of gold. The canopy creates a dappled light environment below, similar to the filtered light of a terrestrial forest floor, but here the pattern is constantly shifting and moving with the waves. No two moments are the same, and the play of light and shadow creates an ever-changing underwater theater. It is a spectacle that has been playing out for millions of years, long before humans ever glimpsed it. The canopy is the kelp forest's interface with the outside world, the boundary where ocean and atmosphere meet. Push your hand up through the fronds and break the surface, and you feel the sudden change from liquid to air, from cool water to warm sun. This boundary is dynamic, rising and falling with the tide, surging with the waves, and the kelp must constantly adapt to these changing conditions. At low tide, some fronds may be exposed to air for brief periods, while at high tide, the canopy sits deeper below the surface. The kelp has evolved to tolerate this variation, its pneumatocysts adjusting their buoyancy to keep the fronds optimally positioned for photosynthesis regardless of the tide's position. It is a masterclass in adaptation, thriving in an environment that is constantly in flux. Life in the canopy is intense and competitive. Here, with abundant light and warmth from the sun, photosynthesis occurs at its maximum rate. The fronds produce sugars and oxygen, feeding not just the kelp itself, but the entire ecosystem below. Yet with this productivity comes vulnerability. Sea urchins, those spiny grazers of the seafloor, occasionally climb the stipes to feast on the nutritious fronds. Herbivorous fish nibble at the edges. Even marine isopods, tiny crustaceans related to pillbugs, bore into the pneumatocysts, causing them to deflate and the fronds to sink. The canopy is under constant assault, yet it endures through sheer productivity. The kelp grows faster than it can be consumed, replacing damaged fronds with new growth from below, staying one step ahead of its herbivores in an evolutionary arms race. From above the surface, the kelp canopy appears as dark patches on the water, floating mats of vegetation visible even from shore. Sailors and fishermen have long used these patches as navigational aids and as indicators of good fishing grounds. Seabirds know the canopy as well, diving through it to catch fish sheltering below. Cormorants and pelicans plunge from the air, using the kelp as cover to approach their prey before striking. The canopy thus connects the marine and terrestrial worlds, serving as a landmark, a hunting ground, and a bridge between ecosystems. It reminds us that the ocean's edge is not a wall but a permeable membrane where air-breathing and water-breathing creatures interact and depend on one another. Beneath the canopy, the temperature is noticeably warmer than in the depths below. The fronds absorb sunlight, and that energy warms the surrounding water, creating a thermal stratification in the forest. This warm surface layer is attractive to certain fish species that prefer higher temperatures, and it also accelerates the growth of young kelp plants that drift in the plankton before settling. The canopy thus creates its own microclimate, modifying the physical environment in ways that benefit numerous species. It is yet another example of how kelp does not merely exist in its environment, but actively shapes it, engineering an ecosystem through its growth and structure. As you float beneath the canopy face upward, watching the fronds sway overhead, you experience a profound sense of peace. The rhythm of the waves translates into the gentle rocking motion of the kelp, and the filtered light pulses with a soothing cadence. Sound is muted here, the kelp dampening the noise of the surface and creating a quiet that is almost meditative. Close your eyes for a moment and simply feel the motion, the coolness of the water, the occasional brush of a frond against your shoulder. In this moment, you understand why so many people find the ocean calming, why the kelp forest has become a symbol of underwater tranquility. It is a place where time seems to slow, where the chaos of the surface world fades, and where you can simply be present with the natural world. But the canopy is not static. Storms can tear it apart, ripping fronds away and opening the forest to the full force of the sun. These disturbances, while destructive in the moment, are also part of the forest's natural cycle. They prevent any single kelp plant from dominating, they reset portions of the ecosystem, and they create opportunities for new growth and new colonization. The kelp forest is resilient precisely because it is dynamic, because it has evolved to withstand and even benefit from periodic upheaval. As you prepare to descend back into the forest's interior, you take one last look at this luminous canopy and recognize it not as a permanent structure, but as a temporary moment in an ongoing dance between growth and destruction, life and renewal. Descending from the canopy back into the mid-water zone, you begin to notice the true diversity of life that calls the kelp forest home. This is not a wilderness, but a metropolis, densely populated with residents of every description. Schools of fish move through the kelp like commuters, each species following familiar routes and schedules. Invertebrates cling to every available surface, from the kelp itself to the rocks below. Even the water column seems alive, filled with tiny crustaceans, jellyfish, and larval forms of larger creatures. Everywhere you look, life is happening, organisms interacting in complex webs of feeding, mating, and competition. The kelp forest supports more species per square meter than almost any other marine habitat, rivaling even coral reefs in its biodiversity. Among the most common residents are the various species of rockfish that make the kelp forest their permanent home. These fish rarely venture into open water, preferring the shelter and abundance of the forest. Different rockfish species occupy different niches, some staying near the bottom, others hovering mid-water, still others lurking in the canopy. Their coloration varies by species and habitat, from the bright reds and oranges of deeper dwelling varieties to the mottled browns and blacks of those that blend with the kelp. Watch a copper rockfish patrol its territory, its movements deliberate and confident, and you see an animal perfectly adapted to its environment. These fish can live for decades, some species reaching over 100 years, making them among the longest-lived fish in the sea. Smaller fish dart between the kelp with nervous energy. There lies a constant balance between feeding and avoiding being fed upon. Señoritas, bright orange fish with a distinctive black spot, act as cleaners, picking parasites from larger fish that hover patiently while being groomed. Kelp perch, as their name suggests, spend their entire lives in the forest, even giving birth to live young rather than releasing eggs into the open ocean. Watching these small fish, you appreciate the incredible diversity of life strategies that have evolved in this habitat. Some fish migrate daily between the kelp and open water. The others never leave. Some are solitary. Others form massive schools. The kelp forest accommodates them all, providing niches for every strategy. Invertebrates are even more diverse than the fish, occupying every conceivable niche in the forest. On the rocks below, sea stars in every color of the rainbow slowly traverse the substrate, their tube feet carrying them in search of prey. Some, like the sunflower star with its multiple arms, are voracious predators capable of catching and consuming surprisingly large prey. Others, like the bat star, are scavengers, feeding on detritus and dead material. Sea cucumbers lie in crevices, extending their feeding tentacles to capture plankton. Sea urchins graze on kelp and algae, their sharp teeth capable of wearing through even the toughest tissue. Each species plays its role, and together they form a community that processes energy and nutrients with remarkable efficiency. Among the most charismatic inhabitants are the nudibranchs, shell-less snails that crawl across kelp and rock in search of specific prey. These creatures are often brilliantly colored, with patterns and hues that seem impossibly vivid. A Spanish shoal nudibranch glides past, its purple body decorated with orange serrata-like flames along its back. These animals feed on hydroids and anemones, incorporating the stinging cells of their prey into their own bodies as defense. They are slow-moving, relying on their bright colors to advertise their toxicity to potential predators. Watching a nudibranch make its way across a kelp frond, you marvel at the intricacy of evolution, how even a simple snail can become a work of art, a warning, and a predator all in one elegant package. Crustaceans of all sizes inhabit the forest, from microscopic copepods in the water column to large sheep crabs walking on the seafloor. Hermit crabs occupy abandoned snail shells, swapping homes as they grow. Decorator crabs attach pieces of kelp and sponge to their carapaces, creating living camouflage that allows them to blend seamlessly with their surroundings. Watch a decorated crab move slowly across a rock, and you might miss it entirely, so perfect is its disguise. These strategies for survival, these evolutionary innovations, are on display everywhere you look in the kelp forest. Every animal has found its way to persist, to feed, to reproduce in this competitive environment, and the diversity of solutions is staggering. The kelp forest is also a nursery for many species that will eventually leave for deeper water or the open ocean. Juvenile rockfish too small to fend for themselves in open water find shelter among the kelp fronds. Young lingcod, destined to become apex predators, start their lives hiding in the forest's protection. Even young sharks, small and vulnerable, use the kelp as a refuge from larger predators. The forest's complex structure provides countless hiding places, and its productivity ensures abundant food for growing juveniles. This nursery function is one of the kelp forest's most important ecological roles, producing the next generation of fish that will populate the broader ocean. Without the kelp forest, many commercially important fish species would have nowhere to grow up safely. As you move through this underwater city, you realize that you are witnessing something rare and precious. Kelp forests occupy less than 1% of the ocean's area, yet they support a disproportionate amount of marine biodiversity. They are hotspots of life in a vast blue desert, oases where the right combination of conditions allows complexity to flourish. But they are also fragile, vulnerable to warming waters, pollution, and overharvesting of key species. The inhabitants you see around you have evolved over millions of years to live in this specific habitat, and many could not survive elsewhere. The kelp forest is not just a habitat, but a home, and for countless species it is the only home they have ever known. Understanding this, you feel a renewed sense of responsibility to protect these remarkable ecosystems. In any ecosystem, predators play a crucial role in maintaining balance, and the kelp forest is no exception. As you swim through the mid-water, you sense a change in the behavior of the smaller fish around you. Schools tighten their formations, individuals become more alert. Then you see why. A large cabezon, its mottled skin blending with the kelp, lies motionless on a rock, eyes following the movements of passing fish. This ambush predator relies on patience and camouflage, waiting for the perfect moment to strike. When it does, the movement is explosive and brief, its large mouth engulfing prey in a fraction of a second. The hunt is over almost before it began, and the cabezon returns to stillness, waiting for its next opportunity. Not all predators rely on ambush. Some actively patrol the forest, searching for prey. Lingcod. Among the largest predatory fish in the kelp forest, cruise through the kelp with purpose. These fish can grow to over 5 feet in length and weigh more than 80 pounds. Their mouths are filled with sharp teeth, and they are capable of taking surprisingly large prey, including other predatory fish. Watch a lingcod hunt, and you see power and determination. It investigates crevices, probes beneath rocks, pursues fish through the kelp with relentless focus. Yet despite its prowess, the lingcod must still compete with other predators and contend with the kelp's protective structure. Even apex predators face challenges in the forest's complex environment. From deeper water, larger predators sometimes venture into the forest edges. Seven-gill sharks, primitive predators with an extra gill slit, patrol the boundary between the kelp and the open ocean. These sharks are not the stereotypical open ocean hunters, but are adapted to coastal environments, their broad bodies allowing them to maneuver in shallow water. They feed on fish, rays, and even other sharks, and while they rarely penetrate deep into the kelp, their presence at the forest's edge shapes the behavior of potential prey. Fish that might otherwise venture into open water remain closer to the kelp's protection. The threat of predation, even the possibility of it, influences the entire ecosystem's structure and function. But perhaps the most significant predators in the kelp forest are not fish at all, but marine mammals. Harbor seals and California sea lions are regular visitors, their speed and agility in the water far exceeding that of fish. Watch a sea lion hunt and you witness aquatic mastery. It twists, turns, accelerates, and decelerates with fluid grace, pursuing fish through the kelp with a combination of power and precision that seems effortless. The sea lion can outswim, outturn, and maneuver almost any prey, yet even it must work for its meals. Fish use the kelp's structure to their advantage, darting through narrow gaps where the bulkier sea lion cannot follow. The hunt becomes a high-speed chase through a three-dimensional maze, predator and prey testing their limits. The most beloved predator of the kelp forest, though, is undoubtedly the sea otter. These marine mammals are keystone species, meaning their presence disproportionately affects the entire ecosystem. Sea otters feed primarily on sea urchins, those spiny grazers that can devastate kelp forests when their populations explode. By keeping urchin populations in check, sea otters indirectly protect the kelp, allowing forests to flourish where they might otherwise be reduced to barren rock. Watch a sea otter dive to the bottom, pry an urchin from a rock with its dexterous paws, return to the surface, and crack it open using a stone as a tool. This behavior, this use of tools by a marine mammal, is remarkable enough, but the ecological impact is even more profound. The relationship between sea otters, sea urchins, and kelp is one of the best studied examples of a trophic cascade, where the presence or absence of a top predator creates cascading effects throughout the food web. In areas where sea otters have been hunted to extinction or driven away, sea urchin populations explode, devouring kelp faster than it can grow and creating urchin barrens where once lush forests stood. But when sea otters return, urchin numbers decline, kelp recovers, and the entire ecosystem rebounds. This interconnection reminds us that no species exists in isolation, that every organism, from the largest predator to the smallest grazer, plays a role in maintaining ecological balance. Remove one piece and the entire system can unravel. Even invertebrates have their predators within the forest. Octopuses, masters of camouflage and intelligence, hunt at night when many of their prey species are less alert. An octopus can change, not just its color, but its skin texture to match any background perfectly, becoming essentially invisible. It uses this camouflage to approach prey, then strikes with its arms, pulling the victim into its powerful beak. Octopuses feed on crabs, snails, and even fish, and they are remarkably intelligent, capable of learning, problem-solving, and using tools. Encountering an octopus in the kelp forest is a privilege, a glimpse of an alien intelligence that has evolved along a completely different path from our own. Its eyes meet yours, and for a moment you wonder what it makes of this strange, clumsy mammal invading its domain. The presence of predators creates a landscape of fear in the kelp forest, areas and times when prey species alter their behavior to reduce risk. Fish may feed less actively when predators are present, accepting hunger over death. They may remain closer to shelter, sacrificing access to better feeding grounds for increased safety. This trade-off between feeding and avoiding predation shapes the daily lives of countless organisms and influences everything from where species live to when they are active. The kelp forest is not just a physical structure, but a complex web of relationships, many of them adversarial, all of them essential. Predators and prey have co-evolved for millions of years, each adapting to the other's strategies in an endless evolutionary race with no finish line. There is a rhythm to the kelp forest that transcends the mere mechanics of survival. If you pause and simply observe, you begin to notice patterns and movements that have an almost choreographed quality. The kelp itself sways with the ocean surge, bending and recovering in smooth, sinuous motions that follow the period of the waves above. This is not random movement, but a response to force, the kelp yielding to energy it cannot resist yet, never breaking under the strain. Watch a single stipe move through its cycle and you see elegance in action, a demonstration of how flexibility can be a form of strength. The kelp does not fight the ocean, it dances with it. The fish of the kelp forest have learned to use this rhythm to their advantage. Schools of baitfish pulse in synchrony with the kelp's movement, darting forward on one surge, retreating on the next, using the energy of the ocean to conserve their own. Individual fish hover in place by making subtle adjustments to their fins and body position, reading the water's flow with sensory organs along their lateral lines. They are not fighting the current but riding it, finding pockets of calm in the midst of motion. This is mastery of environment, an intimate knowledge of how water moves and how to exist within its flow. It is energy efficiency refined over millions of years of evolution. Even the invertebrates participate in the dance. Anemones extend and retract their tentacles with the pulse of the water, maximizing their exposure to passing plankton while minimizing resistance to strong currents. Feather stars, relatives of sea stars, cling to high points on rocks and kelp, spreading their feathery arms into the current to filter feed. When the surge becomes too strong, they curl into protective balls, weathering the turbulence before opening again when conditions calm. Everything in the forest moves in response to the same forces, creating a kind of underwater ballet where every organism is both dancer and choreographer, responding to partners seen and unseen. Light plays its own role in this aquatic dance. As the sun moves across the sky and waves pass overhead, the pattern of illumination in the forest constantly changes. Shadows lengthen and shorten, bright patches appear and vanish, and everything is painted in shades that shift from moment to moment. This changing light creates an environment that never looks the same twice, a kaleidoscope of green and gold that transforms the familiar into the fantastic. Fish that were clearly visible one moment become silhouettes the next as they move between light and shadow. The kelp itself seems to glow when backlit, its fronds becoming translucent curtains of amber. In this ever-changing theater, you are both audience and participant. There are moments of stillness too, brief pauses between surges when the forest seems to hold its breath. In these moments, particles hang suspended, fish hover motionless, and even the kelp stands vertical and still. It is as if the entire ecosystem is waiting for something, poised in anticipation. Then the next surge arrives, energy pulses through the water, and the dance resumes. These moments of stillness are important, offering brief respites in an environment of constant motion. They are the rests between notes in a symphony, the pauses that give the movement its structure and meaning. Without stillness, motion would become chaos. With it, motion becomes dance. The tides add a longer rhythm to the forest's dance, a twice-daily shift in water level and current strength that every organism must accommodate. High tide brings stronger currents from offshore, carrying nutrients and plankton into the forest. This is feeding time for filter feeders and planktivores, a time of activity and consumption. Low tide sees the currents reverse, now flowing back offshore, and the forest becomes calmer. Some areas that were fully submerged at high tide may have their canopy exposed to air at low tide, and organisms in these zones must be adapted to this periodic exposure. The tide is the forest's metronome, marking time in a realm where day and night matter less than the cycle of water rising and falling. Floating on your back beneath the canopy, you allow yourself to move with the forest rather than through it. You sway with the surge, rising and falling with the kelp, becoming part of the dance rather than an observer of it. In this state, boundaries blur. You are no longer separate from the kelp forest, but temporarily merged with it, subject to the same forces, moving to the same rhythms. It is a meditative state, a moment of connection that transcends species and environment. Perhaps this is what draws people to the ocean, this opportunity to experience a different way of being, to surrender control and simply flow with forces greater than ourselves. In the kelp forest's dance, you find a peace that comes from letting go. The dance of the kelp forest is ancient and ongoing, performed long before humans evolved and destined to continue long after we are gone. It is both powerful and fragile, enduring storms yet vulnerable to temperature changes and human impacts. Each sway of the kelp, each passing of light through water, each hunt and escape and birth is a continuation of patterns that have repeated for millions of years. Yet each moment is also unique, never to be exactly repeated. This is the paradox of the kelp forest, simultaneously timeless and ephemeral, permanent and impermanent. To witness it is to glimpse both deep time and the fleeting present, to see how life adapts and endures while acknowledging that nothing lasts forever. Though the ocean seems unchanging, it too experiences seasons, cycles of productivity and dormancy that shape the kelp forest throughout the year. In late winter and early spring, when storms are frequent and intense, the forest endures its harshest conditions. Massive swells tear through the canopy, ripping away fronds and sometimes entire kelp plants. The water is turbulent and murky with sediment stirred from the bottom. For the forest's inhabitants, this is a time of challenge and survival. Yet it is also a time of renewal. The storms clear away old, dying kelp, open space for new growth, and bring deep, nutrient-rich water to the surface. What appears as destruction is actually preparation for the abundance to come. As spring progresses and the storms subside, the forest enters its period of maximum growth. Sunlight strengthens, water temperatures begin to rise slightly, and nutrients brought up by winter storms fuel an explosion of productivity. Young kelp, germinated from spores released the previous year, now grow with incredible speed. In a matter of weeks, they transform from microscopic plants into towering fronds reaching toward the surface. The forest thickens, gaps fill in, and the canopy becomes dense and lush. This is the time of year when the kelp forest most resembles a terrestrial jungle, verdant and bursting with life at every level. Fish spawn, invertebrates reproduce, and food is abundant for every organism in the ecosystem. Summer brings calmer conditions and warmer water, a time when the forest is most accessible to human visitors. The kelp is at its maximum extent. the canopy thick and continuous, providing deep shade to the layers below. Water clarity is typically at its best, visibility extending for tens of meters through the forest. Yet summer also brings challenges. Warmer water temperatures can stress the kelp, which prefers cold conditions. If temperatures rise too high or persist too long, kelp growth slows and some plants may begin to deteriorate. This is also when sea urchin populations can surge if not controlled by sea otters, and herbivorous fish reach peak abundance. The summer forest is beautiful but delicate, balanced on a knife edge between productivity and potential collapse. As summer transitions to fall, subtle changes begin to appear. The sun's angle lowers, reducing the intensity of light reaching the canopy. Water temperatures start to drop as cold, deep water begins upwelling along the coast. The kelp responds by slowing its growth rate, consolidating resources rather than expanding. This is also reproductive time for many kelp species. Patches of reproductive tissue develop on the fronds, releasing billions of microscopic spores into the water. These spores will settle on rocks, germinate, and become the next generation of kelp, though only a tiny fraction will survive to maturity. The fall forest has a sense of completion about it, a cycle coming to a close as organisms prepare for the harsher conditions ahead. Winter returns, and the cycle begins anew. The forest enters dormancy, growth slowing to a minimum as the kelp conserves energy. Storms return with renewed vigor, testing every holdfast's grip on the rocks. Some kelp will not survive, torn away by the fury of the winter ocean. But those that endure, those with holdfasts firmly anchored and stipes flexible enough to bend without breaking, will be the foundation of next year's forest. There is something profound about this cycle, this annual death and rebirth that mirrors the cycles of terrestrial forests. Spring flowers, summer abundance, fall harvest, winter rest. Even in the ocean, far from the influence of changing weather and frozen ground, the seasons assert their rhythm. Beyond the annual cycle, longer patterns also shape the kelp forest. El Niño events, occurring every few years, bring unusually warm water to the Pacific coast. During strong El Niños, water temperatures can rise by several degrees for months at a time, and the kelp suffers. Growth slows, mortality increases, and some forests are reduced to scattered remnants of their former selves. Yet the kelp forest is resilient. When cool conditions return, the remaining kelp releases spores, young plants germinate, and within a year or two, the forest can largely recover. This resilience in the face of disturbance is one of the kelp forest's most remarkable characteristics, a testament to the power of natural systems to heal themselves when given the chance. Climate change now threatens to alter these cycles in fundamental ways. Ocean warming, acidification, and changing current patterns all pose challenges that the kelp forest may struggle to accommodate. If water temperatures rise beyond the kelp's thermal tolerance, if storms become too frequent or too powerful, if ocean chemistry changes in ways that affect calcifying organisms in the ecosystem, the forest as we know it may transform into something quite different. Yet there is hope in the kelp's adaptability, in the speed at which it grows and reproduces, in the potential for populations to adapt to new conditions. The kelp forest has survived ice ages and warming periods, mass extinctions and climate shifts over millions of years. Whether it can survive the rapid changes humans are now imposing remains an open question. Floating in the present-day forest, surrounded by the sway of kelp and the pulse of life, you choose to focus not on what might be lost, but on what exists right now in this moment. The cycles continue, kelp grows and reproduces, fish spawn and feed, predators hunt and prey evade. The ancient rhythms still play out, and the forest still stands. There is power in this continuity, in witnessing processes that have repeated for eons and may continue for eons more. Whatever the future holds, the kelp forest of today is a marvel, a demonstration of life's creativity and persistence. And you are privileged to swim through it, to see it with your own eyes, to feel its rhythm in your bones and carry its memory into whatever tomorrow brings. Humans have been connected to kelp forests for thousands of years, though most people today never realize it. Indigenous peoples along the Pacific coast harvested kelp for food, medicine, and materials long before European contact. The Chumash of California used kelp to create fishing lines and even to fashion into musical instruments. Coast Salish peoples harvested herring eggs laid on kelp fronds in the spring, a delicacy and important food source. The relationship was one of use, but also respect, taking what was needed without destroying the resource. These cultures understood what science has only recently confirmed, that kelp forests are not unlimited and that their health depends on maintaining balance in the ecosystem. The traditional ecological knowledge of coastal peoples contains lessons we are still learning today. In more recent history, kelp has been harvested commercially for the alginates it contains, compounds used in everything from ice cream to toothpaste, from beer to bandages. Kelp harvesting vessels with mechanical cutting equipment operate in kelp forests, mowing the canopy like underwater lawnmowers. When done sustainably, with limits on how much can be taken and requirements to leave sufficient kelp for regrowth, this harvesting can be compatible with a healthy forest. But the history is mixed, with some areas over-harvested to the point where forests struggled to recover. Today, regulations in most regions aim to protect kelp while allowing limited harvesting, a balance between economic use and conservation. It reminds us that humans can use natural resources sustainably, but only with care, limits, and respect for ecological constraints. Kelp forests provide economic value far beyond direct harvesting. They support commercial and recreational fisheries, with many economically important fish species depending on kelp forests as nurseries or adult habitat. Rockfish, kelp base, and many other species caught by fishermen spend critical parts of their life cycles in the forest. When kelp forests decline, fish populations often follow, affecting not just the ecosystem but human communities that depend on fishing for their livelihoods. The kelp forest's value as fish habitat likely exceeds its value for alginate extraction by orders of magnitude, yet this value is often invisible in traditional economic accounting. How do you put a price on a nursery that produces the next generation of fish? How do you calculate the worth of an ecosystem service? Recreation and tourism centered on kelp forests bring millions of dollars to coastal communities annually. Scuba divers travel from around the world to experience these underwater forests, staying in local hotels, eating in restaurants, and hiring dive operators. Kayakers paddle through kelp canopies from above. Nature photographers capture images that inspire conservation. Kelp forests have become icons of marine conservation, their beauty and accessibility making them powerful ambassadors for ocean protection. This recreational value, like the fisheries value, depends entirely on maintaining healthy forests. Degraded or destroyed kelp forests cannot support tourism, and communities lose not just an ecosystem but an economic engine. Conservation and economy are not opposed but intimately linked. Perhaps most importantly, kelp forests contribute to climate regulation and ocean health in ways we are only beginning to understand. Like terrestrial forests, kelp forests absorb carbon dioxide during photosynthesis, incorporating carbon into their tissues. When kelp fragments break off and sink into deep water, that carbon is effectively sequestered, removed from the atmosphere for centuries or longer. This blue carbon captured by ocean ecosystems, may play an important role in climate regulation, though the exact magnitude is still being studied. Additionally, kelp forests produce oxygen, dampen wave energy protecting coastlines from erosion, and filter nutrients from coastal waters. These ecosystem services benefit everyone, whether or not they ever visit a kelp forest, whether or not they even live near the ocean. Yet despite their value, kelp forests face numerous threats from human activities. Pollution from agricultural runoff and sewage can cause algal blooms that block sunlight, preventing kelp photosynthesis. Coastal development increases sedimentation, which can smother young kelp and reduce water clarity. Overfishing of sea otters and other predators that control herbivore populations can trigger the urchin barrens we discussed earlier. Climate change, driven by fossil fuel emissions, warms the ocean and alters currents, pushing kelp forests toward their thermal limits. Each threat alone is concerning, but in combination, they can overwhelm even a resilient ecosystem like the kelp forest. What has stood for millions of years could be lost in decades if we do not act to protect it. But there is reason for hope as well. Conservation efforts are showing results in many regions. Marine protected areas, where fishing and harvesting are limited or prohibited, allow kelp forests to recover and thrive. Programs to restore sea otter populations have seen success, with otters returning to parts of their historical range and kelp forests rebounding in their wake. Even active restoration, where volunteers and scientists manually remove excess urchins or transplant kelp, has shown promise in helping damaged forests recover. When people care about kelp forests, when they understand their value and act to protect them, these ecosystems can be saved. The question is not whether we can protect kelp forests, but whether we will choose to do so. As you reflect on this connection between kelp forests and humanity, you realize that these underwater forests are not separate from us, but part of our world, our responsibility, and potentially our future. The health of kelp forests reflects the health of our coastal oceans, which in turn affects global climate, food security, and the well-being of billions of people. Protecting kelp forests is not just about saving beautiful places for their own sake, though that would be reason enough. It is about maintaining the natural systems that support civilization, that provide the oxygen we breathe, the food we eat, and the stable climate we depend on. The kelp forest is a microcosm of our relationship with nature, a test of whether we can learn to live sustainably on this planet we share with countless other species. Despite decades of research, the kelp forest still holds secrets, phenomena we have observed but do not fully understand. Scientists continue to discover new species in kelp forests, including fish and invertebrates that somehow evaded detection despite thousands of research dives. How many species remain undiscovered in the hidden crevices and deep shadows of the forest? And how many relationships between organisms have we not yet observed? The kelp forest reminds us that even in well-studied ecosystems near major population centers, nature retains mysteries. There is something humbling about this, standing at the edge of the unknown with our impressive but incomplete understanding. The forest invites not just observation but curiosity, not just answers but better questions. One of the great mysteries concerns the kelp itself and how it senses and responds to its environment. Kelp lacks a nervous system, eyes, or any organs we would recognize as sensory, yet it clearly responds to light, growing toward it with precision. It responds to damage, increasing growth rates in areas where tissue has been removed. It even appears to respond to water motion, developing stronger holdfasts in areas of high turbulence. How does a plant without a brain accomplish all this? What mechanisms allow it to perceive and react to its environment? These are not merely academic questions, but insights into the fundamental nature of life, the minimum requirements for something to be considered aware of its surroundings. The communication and interaction between species in the kelp forest also holds mysteries. We know that some fish species respond to chemical signals released by injured fish, alerting them to danger. We know that some invertebrates release chemical cues when predators are near, changing the behavior of nearby organisms. But how extensive are these chemical communication networks? Do kelp plants communicate with each other or with other species through chemical signals? Recent research in terrestrial forests has revealed sophisticated underground networks through which trees share resources and information. Could something similar exist in kelp forests? Connections we cannot see with our eyes, but that fundamentally shape the ecosystem's function. The possibility is tantalizing and largely unexplored. We also do not fully understand how kelp forests will respond to the combined pressures of climate change, ocean acidification, and other anthropogenic stresses. Will they adapt, gradually shifting their range poleward as waters warm? Will they be replaced by other algae species, better suited to warmer conditions? Could they collapse entirely in some regions, creating ecosystem state shifts from which recovery is difficult or impossible? Scientists are working to answer these questions through experiments and long-term monitoring, but predicting the future of complex ecosystems is notoriously difficult. Too many variables, too many interactions, too many potential tipping points. We know change is coming, but exactly what that change will look like remains uncertain. The deep sea off the continental shelf represents another frontier. While we know kelp forests exist in shallow coastal waters, we are less certain about what grows in the dimly lit waters at the maximum depth where kelp can survive, typically around 100 feet in clear water. These deep kelp forests, at the very edge of the photic zone where light still penetrates, are difficult to study and rarely visited. Do they host unique communities of organisms adapted to low light? Do they function differently than shallower forests? Recent advances in underwater technology, including remotely operated vehicles and advanced diving equipment, are allowing scientists to explore these deeper forests, but much remains to be learned. Even basic questions about kelp reproduction and dispersal remain incompletely answered. Kelp releases billions of spores, but we do not know how far those spores travel on ocean currents before settling. Do kelp forests function as connected networks, with spores from one forest colonizing another miles away? Or does each forest primarily seed itself with limited exchange between populations? Understanding dispersal is crucial for conservation, helping us determine how large and how closely spaced protected areas need to be to ensure kelp forests can recover from disturbances. It is also fascinating from an evolutionary perspective, revealing how populations maintain genetic diversity or become isolated over time. Perhaps the deepest mystery is one of consciousness and experience. What is it like to be a fish in a kelp forest? What does an octopus perceive as it hunts among the fronds? Does a sea urchin have anything resembling an experience of its world, or is it merely a biological machine responding to stimuli? These questions touch on philosophy as much as science, probing the nature of awareness and the boundaries of mind. While we may never fully answer them, asking these questions changes how we relate to the kelp forest and its inhabitants. It encourages empathy, respect, and wonder. It reminds us that the universe as experienced by other creatures may be fundamentally different from our own experience, alien yet real, forever mysterious yet worthy of our consideration. In the face of all these mysteries, we might feel overwhelmed or discouraged by how much remains unknown. But there is another way to see it. The persistence of mystery in the kelp forest means there is still wonder to be found, still discoveries waiting, still reasons to explore and study and protect. A completely known world would be a poorer place, offering no surprises, no possibility for revelation. The kelp forest's mysteries are gifts, invitations to curiosity and exploration that can last a lifetime. Whether you are a scientist dedicating your career to understanding these ecosystems, or simply a visitor spending an hour swimming through the fronds, the mysteries enhance the experience. They whisper that there is always more to discover, always deeper levels of understanding to achieve, always another question to ask. Our journey through the kelp forest is drawing to a close, and it is time to begin the ascent back to the surface. But before you leave, pause for one final moment here in the heart of the forest. Look around at the towering stipes, the swaying fronds, the countless lives playing out in every direction. Listen to the muted symphony of the underwater world, the creak of kelp stipes bending, the subtle sounds of fish and invertebrates going about their business. Feel the cool water against your skin, the gentle surge rocking your body, the sensation of weightlessness that makes you feel like you are floating in space. Imprint this moment in your memory, because while you will soon return to the world of air and gravity, the kelp forest and its lessons will stay with you. As you begin to rise through the water column, ascending along a kelp stipe as if climbing a ladder toward the light, you reflect on what you have learned. The kelp forest has taught you about adaptation, about how organisms can thrive in environments that seem hostile to life. It has shown you the importance of connection, how every species depends on others in an intricate web that supports them all. It has demonstrated resilience, the capacity of nature to recover from disturbance when given the chance. And it has reminded you of fragility, how quickly an ecosystem can shift from healthy to degraded when key elements are removed or when conditions change beyond tolerance limits. These lessons apply not just to kelp forests, but to life itself. You pass through the understory zone one last time, saying a silent farewell to the rockfish hovering among the fronds, to the nudibranchs slowly traversing their kelp highways, to the octopuses hiding in their dens. Each of these creatures will continue their lives after you are gone, oblivious to your visit, yet somehow participants in this shared experience. You have been a guest in their home, and the etiquette of being a good guest applies here as surely as it does on land. Take only memories, leave only bubbles, and carry forward a sense of responsibility for the wild places you are privileged to visit. The kelp forest does not belong to us, but we belong to the community of life that includes kelp forests and all other ecosystems. The canopy appears overhead, and you rise into that layer of golden light one final time. The fronds part as you ascend, creating a curtain through which you pass. You break the surface, and suddenly the world changes. Sound returns, the rush of wind and the crash of waves replacing the muted underwater acoustics. Gravity reasserts itself, and you feel heavy again after the weightlessness below. Air fills your lungs, and while it is refreshing, part of you misses the cool embrace of the water. You float on your back, looking at the sky, but your mind is still in the forest below. It is always like this when leaving the ocean, a sense of departure from something important, a reluctance to return to the ordinary world. Swimming toward shore, you watch the kelp canopy from above, seeing it now from the perspective of seabirds and boaters. The dark patches of floating fronds stretch along the coastline, marking the forest's extent. From this vantage point, you can see how the kelp follows the contours of the rocky bottom, growing thick where substrate is suitable, absent where sand dominates. You notice other people on the shore, walking, playing, completely unaware of the complex ecosystem that exists just beneath the surface a few dozen meters away. How many people live near kelp forests without ever knowing they are there? How many pass by these underwater cathedrals every day without suspecting the beauty and complexity that lies hidden beneath the waves? You feel a sudden urge to tell them, to share what you have seen, to help them understand what treasures exist in their own backyard. Reaching the shallows, you stand and walk through the surf, leaving the ocean behind. Water streams from your body, and you feel the weight of your equipment, so light underwater but heavy now in air. You turn back to look at the sea, and it appears unchanged, the same waves breaking, the same blue expanse stretching to the horizon. But you are changed. You have seen what lies beneath. You have witnessed the kelp forest in its full glory, and you cannot unsee it. This is both a gift and a responsibility. You now know what is at stake when we talk about ocean conservation. You understand what we stand to lose if kelp forests decline. And perhaps most importantly, you have experienced firsthand the wonder that makes conservation worth fighting for. In the days that follow, you find yourself thinking about the kelp forest at unexpected moments. Waiting in traffic, you remember the slow, graceful sway of the kelp and the patience it teaches. Facing a difficult decision, you recall how the kelp bends rather than breaks, adapting rather than resisting. Feeling disconnected or isolated, you think of the incredible web of relationships in the forest, how every organism is linked to every other in ways both obvious and subtle. The kelp forest has become a touchstone, a reference point for understanding your place in the larger web of life. This is what happens when you truly immerse yourself in nature. It seeps into your consciousness and changes how you see everything else. You may also find yourself becoming an advocate, someone who speaks up for kelp forests and the ocean more broadly. Perhaps you share your experience with friends and family, showing them photos or videos and trying to convey what it was like to swim through that underwater world. Perhaps you support organizations working to protect marine ecosystems, donate to ocean conservation, or participate in coastal cleanups. Perhaps you make choices in your daily life with the kelp forest in mind, reducing plastic use, supporting sustainable seafood, or lowering your carbon footprint. These actions may seem small, but collectively they matter. The kelp forest does not need everyone to become marine biologists, but it does need people who care, who understand its value, and who are willing to act to protect it. The kelp forest waits for you, patient and timeless, ready to welcome you back whenever you choose to return. And you should return, because one visit is never enough to fully understand such a complex ecosystem. Each visit reveals new aspects, new behaviors, new connections you did not notice before. The forest changes with the seasons, with the time of day, with the luck of what animals happen to be present. No two dives or swims are ever identical, and veteran kelp forest explorers with thousands of hours underwater will tell you they still see things that surprise them, still encounter mysteries that make them wonder. The forest is inexhaustible in its capacity to teach and inspire, offering a lifetime of discovery to those willing to return again and again. If you are new to diving or snorkeling, the kelp forest is an excellent place to develop your skills and comfort in the water. Its relatively shallow depths and protected locations make it accessible to beginners, while its complexity and biodiversity ensure that even experts remain engaged. Dive operators along kelp forest coastlines offer guided tours, providing not just safety but interpretation, pointing out organisms and behaviors you might otherwise miss. Or you can explore independently if you have the training and experience, following your own curiosity wherever it leads. Either way, the key is to move slowly, observe carefully, and remain present in the moment. The kelp forest rewards patience and attention, revealing its secrets to those who take the time to look. Even if you never visit a kelp forest in person, you can still connect with these ecosystems and support their conservation. Documentaries, books, and virtual reality experiences can transport you to the kelp forest from anywhere in the world. Following marine biologists and conservation organizations on social media provides regular updates on kelp forest research and protection efforts. Learning about the products you use that contain kelp-derived ingredients creates awareness of your connection to these ecosystems. And simply appreciating that such places exist, that our planet harbors such complexity and beauty, enriches your understanding of Earth and your place on it. The kelp forest belongs to all of us as part of our planetary heritage, whether we live near a coastline or thousands of miles inland. For those who do have access to kelp forests, consider making repeat visits throughout the year to witness the seasonal changes we discussed earlier. Visit in winter to see the forest battling storms, in spring to witness the explosion of growth, in summer to enjoy maximum visibility and calm conditions, in fall to observe reproductive activity. Each season offers different experiences and insights. You might also try visiting the same site at different times of day. The forest at dawn, with low-angle sunlight creating dramatic lighting, feels different from midday's uniform illumination, which in turn differs from the mysterious ambience of dusk. Night diving in a kelp forest is an entirely different experience, revealing nocturnal creatures and behaviors invisible during the day. The forest has many faces, and knowing them all deepens your relationship with the place. Consider also bringing others with you on your kelp forest visits. Share the experience with family and friends, especially young people who are still forming their relationship with the natural world. A childhood visit to a kelp forest can plant seeds of conservation that grow over a lifetime. Take photos and videos, but do so mindfully, ensuring that your documentation does not become a barrier between you and direct experience. The goal is to enhance your engagement with the forest, not to view it only through a screen. And always follow ethical guidelines for wildlife observation, maintaining appropriate distances, never touching or harassing animals, and leaving no trace of your visit except perhaps some data contributed to citizen science projects that help researchers monitor kelp forest health. The kelp forest also invites artistic engagement. Poets have written verses inspired by the sway of kelp. Painters have captured its golden hues and dancing light. Photographers have devoted careers to documenting its inhabitants, and musicians have composed pieces that echo its rhythms. If you are artistically inclined, consider how you might express your kelp forest experience through your chosen medium. Art has the power to reach people emotionally in ways that scientific information alone sometimes cannot. A beautiful photograph, a moving poem, or a haunting piece of music inspired by the kelp forest can inspire conservation action in others, creating ripples that extend far beyond your personal experience. The forest welcomes not just scientific study, but creative interpretation and emotional engagement. As climate change and other pressures mount, the kelp forests of today may not be the same as those of tomorrow. This creates a certain urgency around visiting and appreciating these ecosystems while they remain relatively intact. We are living in a pivotal moment in the history of kelp forests, a time when human choices will determine their fate for centuries to come. Future generations may look back at this era and judge us by whether we protected these extraordinary ecosystems or allowed them to decline. By visiting kelp forests now, by learning their stories and forming emotional connections with them, you become part of the constituency that will fight for their protection. Your voice, informed by direct experience, carries weight in conservation debates. The kelp forest needs advocates, and advocates need the kind of deep knowledge that only direct experience provides. So the invitation stands open and enduring. The kelp forest awaits your return, whether that return comes next week or next year, whether you come alone or with companions, whether you stay for an hour or spend the day. It will be there, swaying with the surge, pulsing with life, offering beauty and wonder and lessons to anyone willing to submerge themselves in its embrace. Each visit is a gift, an opportunity to step outside the human world and into the larger community of life on Earth. Each return deepens your understanding and strengthens your connection. The kelp forest is calling, and it is inviting you not just to visit, but to belong, to recognize yourself as part of the ocean's story, a story that began billions of years ago and continues into a future that you will help shape. Will you answer the call? Thank you for joining me on this journey through the kelp forest, an hour spent among the swaying fronds and the creatures that call them home. I hope you leave this experience with a renewed sense of wonder for the ocean and the complex ecosystems it contains. Remember that kelp forests exist in a delicate balance, dependent on clean water, stable temperatures, and the presence of key species like sea otters. Your choices matter, from the seafood you eat to the carbon footprint you leave. If this video brought you peace or sparked your curiosity, consider supporting kelp forest conservation efforts or simply sharing this video with someone who might appreciate its beauty. The kelp forest has been here for millions of years, but its future depends on the actions we take today. Until we meet again in another cosmic calm journey, may you carry the rhythm of the kelp forest with you wherever you go.